I will be discussing the problem statement graph valid tree. The problem statement says given n nodes labeled from 0 to n minus 1 and a list of undirected edges, each edge is a pair of nodes. Write a function to check whether these edges make up a valid tree. You can assume that no duplicate edges will appear in edges. Since all edges are undirected, 0, 1 is same as 1, 0 and thus will not appear together in edges. A tree is a valid tree if it cannot have loops and every node needs to be connected. Take input nodes and edges and then check are they connected and do they not have a loop. Using these edges we need to create an adjacency list. Basically we need to know what neighbors we need to figure out what neighbors does each node have. Create a list of neighbors for every single input node. Once we get the list, it will be easy to traverse the graph and we can perform our check to make sure that it is a tree. If the number of visited nodes matches the input value of nodes, that means every node inside the graph is connected. In order to save the problem from false positive loop, we will create a prev variable which stores the previous visited node. The solution code first handles the edge cases where n is equal to 0, which is trivially a valid tree, then build an undirected adjacency list for all n nodes. It uses DFS starting from node 0 to verify the essential tree properties at once, no cycles and full connectivity. During DFS, you can come. The visit set track. No problem.
I locked myself out.
Oh, okay.
Okay. I'm thinking of the work on class too.
Okay. The visit set track nodes that have already been seen. If a node is revisited, a cycle exists and the function returns false. The prev parameter is crucial because it prevents falsely detecting the immediate parent edge as a cycle in an undirected graph. After the DFS completes, the final return condition checks that DFS succeeded, no cycles found, and that all n nodes were visited, ensuring the graph is connected. So the big picture pattern for the interview gold is most graph problems are variations of build adjacency list, DFS, BFS, track visited, state, detect cycles or reachability, validate constraints. If we are able to master this template, then we can solve 70 to 80% of graph questions with confidence.